Okay, team, we are going to solve this problem using shells, which is another way of finding the volume of a figure, right? We talked about the discs, we talked about the washers today. Now I'm going to teach you how to use shells, and I'm going to tell you why it's useful. So, step one, as usual, is to draw a picture. Here you go. We're bounded by y equals 4 minus x squared. So 4 is up here. Negative x squared makes a nice downward-facing parabola. Y equals x, that's this line right here, and x equals 0, which is this line. So we're bounded by these things, so we're talking about this little piece right here. So let me just clear the rest of it off. We're just talking about that piece. Yeah, cool. So then it tells us we've revolved this about the y-axis. So we've taken this and twisted it around this y-axis right here. So I don't know, you can kind of picture it's some sort of shape that looks like this. It asks you now to use shells to find the volume. So normally, if we were doing this using discs or washers, right, we'd draw a line or like a shape or a rectangle perpendicular to where we're rotating it around, and then we'd rotate it and we'd have to use it with respect to y, which we can do, and that'd be awesome, and we're gonna do. But there's another way. So we can still use this with respect to x. So x is going to be our x-axis, and let's draw our new shape perpendicular to the x-axis so we can integrate with respect to x. But we're still going to rotate around y. And as you can see, it makes this sort of cylinder instead of a disc or a washer. So think of it like a tree stump. Think if you had a tree stump and you're trying to find the volume of that. Think about like the rings of a tree. That's what it is. That's what I want you to picture a cylindrical shell as. Is like if you have enough of those shells, eventually they all add up to the volume of the tree stump. Yeah? So that's what you're doing here. You're finding like a little piece and then you're rotating it and then it creates this cylinder shape. So the shell of a cylinder looks like this. The area of the outside is like the circumference of a circle. So it's 2 pi r. And then if you want to find the full volume, I guess, then you got to times it by the height, h. So after we've drawn a picture, instead of finding an equation for the area of the little piece, like usually it's a circle, right, or a square, like in the pyramid example we did, now we're finding the equation for the area of this cylindrical shell. So we're going to start with 2 pi. That's always there. And then we're going to do the radius, and then we're going to do the height. So we can keep this in terms of x, which is really convenient, and let's figure out what this is. So if you can see this cylinder thing that's happening here, the radius goes from the center to the side. And it's going to go like this all the way over till we hit here. Once we get there, then it's teeny, it's gone. So that's basically, if you look, starts at 0 and goes over to just our x value. The radius is just x. That's how far over it goes. So our radius is just going to be x. Now let's think about the height. So the radius depends on the x value, and the height is stretched. And it's not just the y value because it doesn't go all the way down to the x-axis. So it starts up here at this y value, but then it stops when you get to this line. So if you want to find the height of these various cylinders, you got to take this top equation. This is the curvy one. This is the 4 minus x squared. 4 minus x squared. And then you need to subtract off this bottom piece, which is x, minus x. So that's the equation for finding the height. 4 minus x squared minus x. Hopefully that's what it makes sense. And this is it. This is the equation of all these cylindrical shells, and then you just need to now add them up. So if you'll remember from class, step 3 is to find our bounds of integration. So we need to figure out how far over this goes. And you probably don't know off the top of your head, but what you would do is you'd find where 4 minus x squared is equal to x, where these two intersect. Now if you move that over, you can't factor it, so you'll need to use a calculator to figure out what it is. Luckily, I already did it for you. You're welcome. They intercept at 1.562. So you can use that as your bounds for integration. So now we're going to integrate from 0 to 1.562 of this whole thing. So the 2 pi is a constant. It can come out front. This we can distribute in. So we get 4x minus x to the third minus x squared dx with respect to x. So we're integrating with respect to x because the pieces that we drew were perpendicular to the x-axis, but we're using, even though we're rotating around the y-axis. So that's why this is convenient for us. Now just take the integral. You can do that by hand, right? The integral of 4x, you can just do 4x squared over 2 minus x to the 4th over 4 and x to the 3rd over 3. And then you'll plug in 1.562, and then don't forget about the 2 pi that's out front. So do those calculators by hand, check yourself, make sure you understand how to do it. If you do it correctly, I believe the answer ends up being 13.327. So try it, check your work, see if you can get that as the solution. But that's your sort of introduction to another way to find volume of weird areas and shapes.